Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is preparing aldehydes and ketones from acid chlorides and nitriles, two genuinely reliable synthetic routes. Let's begin. Acid chlorides, arcosilel, can genuinely be reduced selectively to aldehydes using hydrogen gas in the presence of a palladium catalyst that's been deliberately poisoned with barium sulfate. This specific combination is called the Rosenmund reduction. The catalyst poisoning is genuinely the essential trick here. Plain palladium catalyst would keep reducing the aldehyde product further, all the way down to a primary alcohol, but the barium sulfate poison catalyst is deliberately weakened enough to stop the reduction at exactly the aldehyde stage, giving genuinely controlled, selective partial reduction. This method is genuinely valuable precisely because directly reducing a carboxylic acid to an aldehyde is otherwise quite difficult. Most reducing agents either don't react with acids at all or reduce them completely down to the alcohol, skipping the aldehyde stage entirely. Nitriles RC triple bond N can genuinely be reduced to aldehydes using stannous chloride, SnCl2, and hydrochloric acid in a process called the Stevens reaction. This forms an intermediate imine which is then hydrolyzed with water to genuinely give the aldehyde directly. This route is especially useful because nitriles are genuinely easy to prepare from alkyl halides through a simple substitution with cyanide ion. Alternatively, nitriles can genuinely be reduced with diisobutyl aluminum hydride, DIBOLH, at low temperature, specifically -78 degrees Celsius, which forms a stable metylamine complex that only releases the aldehyde upon hydrolysis. This controlled, low-temperature method genuinely avoids over-reduction all the way to a primary amine, which would happen with a stronger, less selective reducing agent like lithium aluminum hydride. The single most frequently tested JEE skill here is genuinely recognizing why control conditions matter so much in each of these methods, whether it's a poison catalyst, a low temperature, or a specific mild reducing agent. The underlying theme across all of them is genuinely the same: aldehydes are more reactive toward further reduction than the starting material, so without careful, deliberate control the reaction would simply proceed too far, past the aldehyde, straight to the alcohol, or the amine. A frequently tested trap involves genuinely working backward from a target aldehyde to correctly identify which starting material and reagent combination would actually work. For an aldehyde RCHO, you'd genuinely need either the corresponding acid chloride RCUCl with Rosenmund conditions, or the corresponding nitrile RCN with Stevens or DIBOLH conditions, and recognizing which starting material is more genuinely available often decides the more practical, sensible choice. Also remember that ketones, unlike aldehydes, are genuinely much less prone to overreduction under these same conditions, since the resulting product would be a secondary alcohol, a comparatively less favorable further reduction pathway. Let's recap. The Rosenmund reduction uses a poisoned palladium catalyst to selectively reduce acid chlorides to aldehydes without overreduction. Nitriles can be converted to aldehydes via the Stevens reaction, using stannous chloride and HCl, or via controlled DIBOLH reduction at low temperature. In every method, the shared challenge is preventing the more reactive aldehyde product from being reduced further, and recognizing this theme is the key to understanding why each method uses such carefully controlled conditions. That's preparing aldehydes from acid chlorides and nitriles. Keep the Rosenmund and Stevens reactions and the shared over-reduction challenge sharp. They're a reliable source of synthesis questions. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.